the world's biggest tunnel boring machine to an abrupt halt. It's just 1,000 feet into a tunnel that's planned to be almost 10,000 feet long. When Western engineers saw footage of China's SLJ 932, nicknamed the Iron Monster, rolling onto a valley and building an entire bridge in hours instead of months, they all said the same thing. This violates every rule of construction we know. Only Chinese engineers can do this because they've turned impossibility into a routine. These heavy-duty machines are why China can build anything anywhere faster than anyone else. And the numbers are staggering. Machines longer than a football field, moving thousands of tons like Lego pieces. But here's the bigger question. How did China leap from zero tunnel boring capability 24 years ago to controlling 70% of the global market today? The answer lies in something no Western nation has ever dared to try. The engineering time machine. Only Chinese engineers can do this. These heavy-duty machines are why China can build anything anywhere at a speed the rest of the world simply can't match. But here's the part that almost no one outside China understands. This isn't just about machines that move faster or cranes that lift heavier. China has quietly built what you could call the world's first engineering time machine. Not a sci-fi device, but something far more disruptive. A system that compresses decades of Western engineering progress into just a few short years. Let me show you what that looks like. At the turn of the millennium around the year 2000, China had exactly 0% share in the global tunnel boring machine market. That's right. They didn't produce a single one. The West had been refining TBM technology for over 150 years. It was considered too complex, too specialized. A club where only a few nations could even play. Fast forward to 2024 and the story looks like something ripped out of an alternate timeline. China now commands 70% of the global market, not just competing, dominating. In less than one generation, they went from importing every TBM to supplying almost every corner of the planet. Now, think about what that means in real-world projects. While California has spent 16 years still trying to complete a single high-speed rail line, China has already laid down more than 40,000 kilometers of high-speed track. And they didn't just build the trains. They built the tunnels, the bridges, the viaducts, everything. The impossible made routine. So, how do you shrink a 150 years of Western progress into just 20 years? The answer is what Chinese engineers themselves call concentrating all national efforts on big issues. Instead of leaving engineering breakthroughs to scattershot corporate research and isolated university labs, China pooled its state resources, its industries, and yes, its people into a synchronized mission. You could almost call it reverse engineering time itself. And this is where the time machine metaphor becomes real. The West took more than a century of trial and error of fragmented private competition to slowly evolve TBM design. China looked at that timeline, sliced out all the waiting, and treated it like a speed run. They imported the first machines, rebuilt them, and then scaled up production with military precision. Ask yourself, what does it mean when a country can erase a century-long gap in less than a quarter of that time? It doesn't just change the machines. It changes the very physics of development speed. And here's the kicker. This isn't about luck or shortcuts. China engineered this acceleration deliberately. By focusing entire industries, universities, and supply chains on the same target, they created a learning curve so steep that Western companies couldn't keep up. Even with their head start, where the US might take 10 years to prototype and approve a new TBM, China could churn out multiple iterations in the same span, improving each time and cutting costs by scale. Now, let me drop a number that should make you sit up. In 2008, when Beijing was gearing up for the Olympics, China still relied on foreign tunnel boring machines. By 2011, just 3 years later, they had developed their first domestically produced model. By 2017, they weren't just making them. They were exporting them to more than 30 countries. And today, 7 out of 10 TBM's boring tunnel worldwide are stamped Made in China. And here's what makes it even more insane. California's high-speed rail project, 16 years in, billions of dollars spent, and not a single completed line. Meanwhile, China has built a nationwide high-speed rail system that stretches from Beijing to the southern coast, linking mega-cities like Lego blocks on steroids. It's not just an engineering flex. It's a time flex. Western engineers often joke that building infrastructure in their countries feels like dragging history through molasses. In China, it feels like watching history on fast forward. So the big question is, how do you outbuild not just a country but a country that's figured out how to outbuild time? And that's the terrifying part for Western policymakers. Because this time compression isn't fueled by luck or accidents. It's powered by something much larger. Something Western governments would never dare to attempt. Imagine an army of 6.7 million engineering students trained with military precision feeding directly into this machine of national development. The 6.7 million engineer army. Only Chinese engineers can do this. These heavy-duty machines are why China can build anything anywhere at a speed the rest of the world just can't match. But the truth is, machines alone don't build bridges across valleys or bore tunnels through mountains. You need people. And this is where China pulls off its biggest flex. While Western nations spend endless hours debating work-life balance, China has built the world's largest engineering education system. Right now, 6.7 million undergraduate students are enrolled in engineering programs across more than 23,000 courses. Let that sink in. That's not just a big number. That's an entire workforce the size of some countries. Trained, disciplined, and funneled directly into infrastructure and innovation. Every year, China graduates around 1.5 million engineers. That's 1/3 of the entire planet's supply. Compare that to the United States, which produces less than 1/4 of that number. So, when people ask, how does China build 10 high-speed rail lines while we're still arguing about one? Well, this is your answer. Now, here's where the cultural clash kicks in. In the West, construction crews work a 9 to 5. Clock in, clock out, weekends off, and projects pause for holidays. Rain, too dangerous. Heat wave, better reschedule. Snow, shut it down. But in China, engineering is treated more like a military campaign than a casual job. Crews work in 3 shifts, 24 hours a day, 7 days a week. Rain, wind, blistering heat, it doesn't matter. The work doesn't stop. You might see a tunnel boring machine pushing through rock at midnight while one crew rests, another steps in and another is preparing behind them. The machine never sleeps, so neither do the teams. And it's not just about brute force. It's systematic. From the classroom to the job site, Chinese engineers are trained to see impossibility not as a barrier, but as a challenge. That mindset shows up in their output. By the end of 2024, China held 3.5 million valid invention patents. But here's the number that should really scare the competition. Over half of those patents, 53.3%, are actually industrialized. Meaning they're not just sitting in a file somewhere. They're in real-world use. Think about that. In many Western countries, patents are trophies. In China, patents are weapons. So what does all of this add up to? It means when a Western engineer says this bridge will take 5 years, a Chinese team can say, no, we'll finish it in 1. And it's not just talk. The workforce is there, the training is there, and the discipline is there. This is why you can drive across a brand new 6-lane highway in Chongqing, completed in a fraction of the time it would have taken in Los Angeles or London. Let me throw this at you. Imagine pitting 1.5 million fresh engineers every year against the West's shrinking pool. Imagine a country that produces more engineers annually than the entire population of some European cities. That's the scale we're talking about. When you multiply that by 20 years, you don't just get manpower, you get a force of nature. And it's not just quantity, it's focus. Those millions of engineers are directed into mega projects, AI, energy, and yes, the heavy-duty machines that make the impossible look like child's play. So the next time you hear about a bridge being finished in record time or a tunnel appearing out of nowhere, remember this. It's not just because of the iron monster or the tunnel-boring leviathans. It's because there's an army of engineers behind them, working relentlessly, trained systematically, and driven by a culture that doesn't stop when the sky gets cloudy. But raw numbers and endless discipline mean nothing without the machines to channel all that talent. And this is where China truly terrifies the West, because the monsters they've built make Western equipment look like toys. Machines that break physics. Chinese heavy machinery doesn't just break records. It breaks the laws of physics as Western engineers understand them. And this is where things start to feel like science fiction made real. Because only Chinese engineers can do this. These heavy-duty machines are why China can build anything anywhere. Take the SLJ 90032. Better known as the Iron Monster. Imagine a machine the length of a football field weighing 580 tons, slowly crawling across a valley. Instead of waiting months for cranes and scaffolding, this beast rolls up, lifts an entire 900-ton bridge span, slides it into position, and locks it in place all in a matter of hours. Western engineers looked at it and said, this shouldn't even work. But it does, thanks to 64 independent wheels that let it shuffle sideways, forward, and back with surgical precision. It's so nimble that it can inch a 91 steel span into place as easily as you slide a plate across a dinner table. And if you think that's wild, wait until you see the world's most powerful crawler crane, the XCMG XGC 88000. On paper, it sounds fake. A lifting capacity of 4,000 tons, a boom that stretches 144 m into the sky, a total weight of over 5,300 tons. To put that in perspective, this crane can hoist a fully loaded Airbus A380 passenger jet straight into the air. Western engineers spent decades perfecting cranes that could handle a fraction of that weight. And China just built one that feels like it belongs in a Marvel movie. In fact, this machine has already been used in petrochemical plants where the modules it lifts are bigger than small buildings. Watching it operate is like watching gravity bend. Now, let's move to concrete pumping. Something that sounds boring until you realize the numbers involved. When workers were building the Shanghai Tower, they needed to push concrete nearly 2/3 of a kilometer into the sky. Most pumps in the West would choke out after a few hundred feet. China's San 86M concrete pump shattered the world record by shooting concrete 621 m high. Picture wet cement traveling higher than the Eiffel Tower. And it worked so flawlessly that it became known as the Pump King. That single achievement meant China could build skyscrapers at speeds no one else could even attempt, and tunnels. China doesn't just build them. It digs them with machines the size of cathedrals. The world's largest tunnel boring machine with a diameter of 16.6 m was designed and built in China. Think of a circular cutter taller than a 5-story building chewing through mountains as if they were sand castles. And they didn't just keep this tech at home. When Australia needed a tunnel boring machine with an excavation diameter of 15.7 m, the largest ever exported, they didn't go to Germany or the US. They went to China. Imagine that. The world's richest Western nations are now importing Chinese machines because nobody else can build them at that scale. And here's the hidden detail most people miss. These machines don't just rely on brute strength. They run on microscopic precision. China's hydropower turbines, for example, are built to tolerances of 0.02 millimeters. That's thinner than a human hair. How do you go from a crane lifting 4,000 tons to a turbine spinning with atomic-level precision? It's the same philosophy. Impossibility is just another engineering problem to solve. And you can see the results everywhere. In Shanghai, that record-breaking pump turned a tower into the world's second tallest building. In Africa, Chinese cranes and tunnelers are shipped straight into mining projects where Western firms said the terrain was too difficult. In Australia, that exported TBM is literally digging the ground Western companies couldn't handle. Now, ask yourself this. If these machines can lift, pump, and cut at scales that make Western records look like toys, what does that mean for global competition? Because remember, these aren't showpieces. They're deployed every day across China's 40,000 kilometers of high-speed rail, its endless urban megaprojects, and its overseas belt and road contracts. They're not sitting in museums. They're out there rewriting physics on construction sites. And here's the scary part. These monsters are just the tools. They're the hammers and scalpels. The real power isn't in the machine itself. It's in how China deploys them at speeds that make Western projects look frozen in time. China speed versus Western paralysis. While Western democracies debate and delay, Chinese engineering operates on what's now known as China speed. It's not luck. It's not recklessness. It's a systematic approach that treats impossibility as a weekend project. Only Chinese engineers can do this. These heavy-duty machines are why China can build anything anywhere at a speed that looks almost alien from the outside. Look at the Hong Kong, Zhuhai and Macau Bridge. 55 kilometers of ocean-crossing highway with artificial islands and underwater tunnels completed in less than a decade. Western engineers called it unthinkable. But in China, it was treated as just another mega project. Now, compare that to California's high-speed rail. 16 years in, $128 billion spent, and not a single train has left the station. Meanwhile, China has already built 40,000 kilometers of high-speed rail in the same time frame. That's enough to wrap around the Earth twice. The difference is night and day. In the West, a project begins with endless studies, community hearings, environmental reviews, lawsuits, counter-lawsuits, and political fights. By the time shovels hit the ground, years, sometimes decades, have passed. In China, they flip the sequence. They build first, refine later. It's an engineering culture that says, we'll fix the details while it's running because the country needs this. Now take the Mombasa-Nairobi Railway in Kenya. Western contractors pitched timelines of up to 10 years. The Chinese finished it 18 months ahead of schedule. Or think about the Shanghai Tower, a 632m skyscraper. Western firms still struggle to pump concrete to those heights without delays. Chinese engineers solved it with machines that pushed concrete higher than the Eiffel Tower floor by floor until the tower pierced the clouds. And here's where it gets wild. Traditional skyscraper construction often takes 3 months per floor. China's modular construction methods can complete 3 floors per day. 3 months versus 1 day. That's not just faster. That's a completely different definition of time. Now imagine what happens when you combine that speed with those monster machines we just talked about. The SLJ 900 bridge builder crawls across valleys like a mechanical centipede, slotting 90m spans into place. China's crawler cranes hoist modules the size of apartment blocks in one lift. Tunnel boring machines slice through mountains like butter. And while they're doing this at home, China is exporting it abroad. The Belt and Road Initiative has spread these capabilities to over 70 countries. Bridges in Africa, railways in Southeast Asia, ports in the Middle East, Chinese machines, Chinese engineers, Chinese speed. So when Western observers dismiss these projects as reckless, they're missing the point. It isn't chaos. It's precision. Every crane movement, every concrete pour, every span laid is backed by a system designed for relentless efficiency. The result is a playbook the West can't copy because it doesn't fit their political culture. And that's why this speed terrifies competitors. Because what Western countries consider impossible, China finishes on a regular Tuesday. And here's the real twist. This speed isn't reckless, it's precise. Chinese engineers have achieved something no one thought was possible. Systematic innovation that makes the impossible routine. The global infrastructure revolution. Chinese engineers aren't just transforming their own country. They're exporting impossibility to more than 150 nations, rewriting the rules of global power through concrete and steel. This is where China's machines become more than tools. They become diplomacy. Today, 13 Chinese companies rank among the world's top 50 construction manufacturers. XCMG has climbed to number 4. SAN sits at number 6, and both now compete head-to-head with century-old Western giants who used to dominate this space. And it's not just rankings on a list. The receipts are massive. The first Chinese mining tunnel boring machine exported to Zambia weighs 800 tons and can cut through rock with a 5.63 m diameter. In Australia, China delivered a 15.7 m TBM, the largest excavation diameter ever shipped abroad because nobody else could build it. And then there's the Belt and Road Initiative across 70 countries. Chinese cranes, bridge builders, and TBMs are laying down ports, railways, and tunnels at speeds Western contractors can't match. Over time, Chinese standards are quietly becoming global standards simply because they get projects finished. This is what experts now call infrastructure diplomacy. Governments aren't choosing Chinese engineering out of loyalty. They're choosing it because it delivers results. Western firms promise, but never seem to achieve. The secret isn't just bigger machines. It's the system. Prefabrication in factories, on-site modular assembly, and a workforce trained to compress timelines. That combination creates a kind of speed and precision the West can't replicate within its political and legal gridlock. And this is the real revelation. It's not about machines or speed alone. It's about a shift in human capability. Only Chinese engineers can do this. These heavy-duty machines are why China can build anything.